This episode of the Pumps and Systems podcast is brought to you by Industrial Flow Solutions, intelligent pumping solutions.
Energy accelerates chemical reactions, right? So being in these steam tunnels, we have a lot of higher rates of corrosivity, higher rates of wear. There's a lot of things that just get accelerated because we have this extreme temperature that we wouldn't see in traditional environments.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today, we're speaking with Arjun Shanmugam and Andrew Pecorillo about pumps operating in extreme conditions. They're going to tell us about steam tunnels and the submersible pumps that operate inside them. So, without any further ado, let's get into the episode. Welcome to the Pumps and Systems podcast. So, we really appreciate you being here. So, how are you doing today?
I'm doing great. Pretty excited to get this kicked off. So,
Same. Yeah, I'm excited to talk about this today and excited to be here. Thank you for having us.
Glad to hear it. Thank you for being here. Okay. All right. So today we're going to be talking about some pumps that are operating in some pretty extreme conditions. But before we get into that, would you mind introducing yourselves? So tell us who you are, what you do, anything that you think our listeners and viewers might want to know.
My name is Arjun Shanmugam, and I'm the Business Development Manager for Industrial Flow Solutions.
And I'm Andrew Pecorillo. I'm a mechanical engineer at Industrial Flow Solutions.
Okay, short and sweet. All right. So moving into our main topic, let's start by talking about steam tunnels. So what are they and why are they important?
So steam tunnels are essentially underground passageways designed to house steam distribution pipes, electrical conduits, and utility infrastructure. They're a pretty integral part of large-scale heating and utility distributions. So where it typically comes into play is in like urban cities where you have commercial buildings like hospitals, universities. These tunnels are an effective way to distribute steam and provide heating solutions. They're a centralized, they allow centralized steam plants to deliver heat and energy to multiple buildings while protecting the infrastructure. And also, it is protected from the environmental threats from outside, like flooding, etc. So instead of running these utilities above ground, where they're exposed to the atmosphere and environment, they're well protected running underground the city.
So what is the environment of the steam tunnel like? Why is it so harsh for equipment and infrastructure?
That's a great question. So, steam tunnels pose a challenging environment, right? Well, one of the most difficult problems with steam tunnels in specific is high temperatures, excessive humidity, and the reaction of humidity along with temperature causes chemical exposure, right? A lot of exothermic reactions that happen at these tunnels. So let's talk about these. Let's break these into three things. I'll go into extreme heat. So you're looking at temperatures anywhere ranging from 200 to 300 degrees Fahrenheit, and possibly even more. So this is a really high temperature environment that your mechanical pumps are operating in. Because of these temperatures and closed environments, it causes a lot of humidity and condensation. And these condensation effectively cause these pools of water and liquid that essentially need to be effectively drained. So when these water accumulation or pools are created in these steam tunnels, they become reactive. So they essentially become a source of a caustic solution that needs to be removed. And so all of these characteristics, which is the extreme heat, the high humidity, and the corrosive nature of the liquid, makes steam tunnels a difficult application to work in.
And we learned from basic chemistry class when you're going through high school, college, all of that, energy accelerates chemical reactions, right? So being in these steam tunnels, we have a lot of higher rates of corrosivity, higher rates of wear. There's a lot of things that just get accelerated because we have this extreme temperature that we wouldn't see in traditional environments.
So you touched on drainage a little bit, But why is proper drainage so important in steam tunnels, and how do submersible pumps help with that?
When you look at drainage and why it's critical in steam tunnels, it's because of the structural damage the condensate water creates, right? So it's corrosive in nature. It damages the equipment. It could be the actual infrastructure of the tunnel itself. Corrodes over a period of time. There's the safety hazards with water pools for maintenance personnel. Could cause short circuit electrical failures, and also increases the risk of equipment failure or fire hazards, right? So typically, these are some of the main reasons as to why you need effective drainage of steam tunnels, and high temperature submersible pumps play a critical role. The core aspect of having a high temp submersible pump is it can operate in much higher temperature ranges than a traditional submersible pump. So traditional submersible pumps can handle temperatures typically up to 104 degrees F. These pumps have a much higher tolerance and can run continuously all the way up 200 degrees Fahrenheit, and super high temps in certain applications can handle a much higher temperature. So these submersible pumps, high temp submersible pumps, are effective in removing these hot pools of water and liquid from these steam tunnels and create a more safer working environment.
So high temperature pumps have a lot of unique specializations that make them suitable for these extreme environments, whether it be material selection, which helps just the pumps function at this higher elevated temperature without overheating. Material selection in terms of corrosion resistance, because again, going back, we see accelerated corrosion, and a lot of other accelerated chemical reactions when you're exposed to this temperature. And then other steps can be taken as well to deal with the high temperatures within the motor. Protections such as filling the motor chamber with oil, changing different things about the motor structure and the motor materials, help it survive in these extreme environments.
This episode of the Pumps and Systems podcast is brought to you by Industrial Flow Solutions. Headquartered in New Haven, Connecticut, USA, Industrial Flow Solutions specializes in the design, manufacturing, sales, and service of wastewater pumps and controls, including Overwatch direct inline pump systems, BJM pumps, Drano pump, StanCore, oil minder, and deragger products ideal for municipal, industrial, commercial, and residential applications. For more information, visit www.flowsolutions.com. Yeah, so it seems like these submersible pumps have to withstand some pretty extreme conditions. So what materials are used in those pumps to help them deal with that?
There's a lot of materials that do work. The ones that tend to be most common are going to be 316 stainless steel is one of the primary ones. 316 stainless has really good corrosion resistance for a lot of situations, especially low pH situations. And it helps deal with one of the most common corrosive effects that happens in these high temperature environments, which is going to be creation of dissolved oxygen or carbon dioxide actually corroding at the material itself, the outer material. Another good material that is used is brass. Brass, though not typically thought of for high temperature because it has a very low melting point, is very good in these scenarios due to its excellent corrosion resistance. It can really fight off the corrosion caused by these carbonic acids and other things that are just in the air from the steam generating process and concentrated beyond what you would typically see in normal situations. You're also going to see a lot of high temperature pumps utilize different elastomers. Some of the more modern ones coming out, you'll see FF cam, which is a parafluoroelastomer. These materials can easily exceed temperatures of 200 F and beyond. And the pumps, just like any submersible pump, you need to make sure you're keeping all of those liquids, those hot liquids, out away from all the electrical components. So using those seals that are rated for the high temperatures, you're ensuring the longevity of high temperature pumps.
So then how do the pumps avoid things like overheating and motor failure when they're in these extreme heat conditions?
In high temperature pumps, there are a lot of steps that are taken to defer the heat to somewhere else, to allow the motor to continue its normal operation with and the cooling that is required from that operation needs to still occur. Oil filling the motor chamber is one. Oil is a much better thermal conductor than air. So filling the chamber with oil allows for the heat buildup during the operation of the motor to leave the motor chamber at an adequate amount of time to keep it within the range of allowable temperatures. Changing the insulation class of the winding stator or the stator windings is another method that's commonly used. Typical submersible motors will have either class F or class H insulation, where a lot of high temperature submersibles, you'll see class R and beyond. These insulation classes prevent failure from shortings occurring within the motor, other things like that. Will prevent it up to 300 degrees Fahrenheit as a minimum. There are some that go even beyond that. And just doing different coatings, internal coatings, varnish coatings. There are a number of different companies that offer varnishes that can survive in these high temperatures. And again, everything that they're doing to the motor is just to prevent this electrical breakdown, to prevent shorts from happening. So any steps that companies take to make these high temperature pumps, they need to really focus on that motor.
So what about critical components like the pump's electrical cable? Like how are those protected from the extreme temperatures?
So just like the elastomers within the pump itself, preventing the water from getting to the electrical components, the cable is an electrical component. So you need to make considerations. You have your copper cable surrounded with the elastomer, and that choice of elastomer becomes important. There are many companies who have proprietary cable elastomers and shielding that help reduce moisture infiltration and reduce the heat infiltration into the cable as well. Copper, just like anything else, like any conductive material, has an ampacity rating to it. As the temperature increases, that ampacity changes. So the amount of electricity that you're able to actually safely transmit through the cable changes. So selecting the proper cabling with the proper shielding and the proper moisture barrier and chemical corrosion resistance is very important when selecting pumps, high temperature pumps, and specifically high temperature pumps for steam applications.
We still have some time left. So do you have any real life stories or examples or anything that you would like to share with us?
Yeah, we actually we have been working on a project for a few years now. We were reached out to by a electrical company that operates steam tunnels in Manhattan, and we've been working with them on creating a product that would survive in these applications. They were using traditional pumps, submersible pumps prior to this, and the life expectancy of those pumps, they had it set to 1 week. They would put a new pump in on Monday, they'd come back the next Monday, and they'd have to do it all over again. That's very costly for them. So they reached out to us about looking into some high temperature options. They came to us with the design challenge of creating a pump that would last for an extended period of time.
One of the few changes that we made is actually using brass hardware as tie rods on the motor housing to prevent the wear. And again, this wear is accelerated by the high temperature and corrosion that occurs. So simple things like that, things where there were changes to the cable to be able to withstand those high temperatures and to prevent deterioration. The motor is a R-class insulated motor that can withstand temperatures up to 200 degrees F on a continuous operation. And the motor is being oil cooled. We're looking at these pumps being installed, and it's almost been over a year now. We're looking to make sure that these operate without any problems or any issues for up to 5 years.
That's a big improvement over 1 week.
Yep.
All right. So before we finish up, is there anything else you'd like to share with us or any final thoughts you would like to leave us with?
So in conclusion, steam tunnels are definitely a difficult application for pumps to work in. You know, in our industry, we always need all of the information as it relates to, you know, the head flow, voltage. It becomes even more critical in applications like steam tunnels for us to design around knowing the actual temperature, the pH of the liquid, and all of the different characteristics of the steam tunnel that could affect the operation of the pump and the life of the pump. So having all this information and choosing the right materials would definitely improve the longevity of your equipment.
Okay, well, thank you so much for being on the podcast. We really appreciate it.
Thank you. Thanks, Tom.
Thank you for having us.
Huge thanks to Arjun and Andrew for taking the time to speak with us today about steam tunnels and submersible pumps. And a big thank you also to Industrial Flow Solutions for sponsoring this episode. If you're listening to the podcast and would like the chance to watch it, stop by our YouTube page to see the full video version. That's going to do it for this episode. Thank you so much for watching or listening, and we will see you next time.